Välkommen tillbaks in hit till studion. Ja, underleverantörsbarometern sannoliken ett intressant case. Vill du veta mer om den så bege dig alltså till SINFs monter här på Elmia. Och jag tror att du är med på hur det här fungerar nu. Ja, vi kommer göra nedslag där ute i mässvärlden där det just nu bubblar för fullt av människor som har längtat efter att få mötas igen. Och vi kommer göra nedslag i de där montrarna. Som sagt, vi kommer vara här i studion, paneldiskussioner, viktiga ämnen. Några av de ämnena får du redan här i eftermiddag. Vi kommer efter lunch få lyssna mer till Tech Arena här från Elmia. Vi kommer prata mer med SINF om hållbarhet. Snacka om ett ämne som har åkt upp högst på den där agendan. Men nu är det dags för InnoDex. Så jag lämnar med varm hand över till Sascha Peters. Varsågod.
My name is Sascha Peters. I am CEO and founder of the future agency Haute Innovation in Berlin. We try to predict the future a little bit by looking to what is happening in the material field right now, because materials are the base for a lot of developments in the industrial world. Now, my next presentation is about advanced and smart materials. And I would like to start with something that Steve Jobs said some years ago, that the biggest innovations of the 21st century will be at the intersection of biology and technology. Last month, there was a report about a winged microchip, which is smallest human-made flying structure right now. It is the work of scientists of the Northwestern University near Chicago that was inspired by the propeller seeds of the maple tree. The movement of the Microfire is comparable to that of propelled maple leaf falling from a height to use it with sensors, for example, to record environmental data. Second example is a technology that transforms structural colors, as you can see it now in this image, to wood-based material, a work done at Aalto University in Helsinki. They were able to have a structure in the surface of wooden boards that reflects light in a way that you can see color where is no color, because it's just the structure. No pigment is used, very sustainable technology, only wood, only cellulose fibers used, and even it works on black and cold burnt wood. It is black, and you could see something in it. Very, very interesting. And there are more interesting examples of using natural materials in the technological context. Maybe you remember an exhibition where we had a coffee cup made from used coffee grounds in there to see. That's a work from a designer from Berlin, Julian Lechner, and now he's working on a watch. World's first watch made completely, not the watch, but the base of the watch is made from used coffee ground. In the technical area, for example, they are trying to bring the coffee grounds, which is mixed with a bioplastic, in that case, to the snowboard, to the sports industry. Snowboard binding made from coffee grounds is now in our exhibition. a cooperation, by the way, with Nitro Snowboards from the US. Natural and sustainable materials are also getting more important in 3D printing. So designers from Milan printed a lamp out of a material based on orange peels from Sicily, which is finally biodegradable, the whole system, not the electronic parts, of course not. Another very interesting technology comes from Switzerland, Swiss Wood Solutions from Zurich. They can densify solid wood in a way and create veneer materials out of it that are able to replace plastics, for example, in credit cards. 100% wood-based, apart from the printed circuit boards, completely harmless to nature. And they are able to replace super strong wooden parts, precise parts, can replace metal. In that case, it's a watch, and you can see the little tiny part made from wood. We have that one in our exhibition. Probably you know that there are developments for metal foam taking place for years now. Fraunhofer scientists are also able to produce a foam made from wood. So they now are thinking about combining metal foam and wooden foam, for example, as a packaging material, a lightweight packaging material for electronic goods. Or why not having hybrids from metal foam and carbon layers as a lightweight material in electric cars with improved crash behavior. That is, by the way, my friend Oskar Zita from Wrocław in Poland, who invented a technology at ETH Zurich couple of years ago to blow up metal sheets to get super strong, lightweight structural solutions. In that case, it's a seat. That was the Plop Hocker, which is quite famous in the design world, and that's his new seat or chair, the Ultra Legera, which is the most lightest chair in the world right now, 1.6 kilogram only. No presentation about smart materials without shape memory alloys that can be deformed when cold, but returns to its pre-deformed shape when heated. At Weißensee University in Berlin, they were successfully integrating SME fibers into shading textiles. We have two demonstrators in our show. In the first model, the SME is activated by high temperature, contracts by about 3%, and slides the entire membrane a little bit upwards, and then closing the whole system for sunlight and open it again if you would love to have the sunlight inside. In the second solution, they worked with a curved textile, with curved textile bands that are interwoven across their entire length with a linear SME wire. And when you thermally heat up the wire, then it contracts by 5% and therefore forcing the band to buckle, and then you can open and close the system for sunlight. Again, probably you know that shape memory alloys can also have a super elastic quality. In that case, NASA makes use of this in developing airless tires for a Mars scenario some years ago. This spring, the first product that makes use of super elastic qualities of the smart memory alloys were launched at the market in the US, smart tire company. It is a bicycle wheel that is made from a nickel titanium alloy. So no air needed. But we didn't get it for the exhibition. I would very, very love to see that bicycle. And another material that is often used in high advanced solutions nowadays is carbon. For example, carbon lightweight structures in airplanes or somewhere else, because carbon fibers are super strong and stiff. So stiff that scientists from Stuttgart University find a method to produce sound wave guides from it for example, flat loudspeakers, so flat that they can integrate a loudspeaker into a door of a car. It only needs 0.5 watt, so very little energy to bring the sound in the system, and there are options for textile industry. So you can just put the carbon waveguide onto the jacket, and then you hear the sound. Or in that case, we have a car door in our exhibition to show the possibilities how to integrate the flat loudspeaker into the car industry. But other industries are also possible to use that technology. We have a jacket in our exhibition, the so-called, it's not a jacket, it's a hoodie. So that's made of a textile from Switzerland with a ceramic coating. So it's called ceramic hoodie from a company from London, Followback, their name. And this is super abrasive, super high resistance, so very, very interesting textiles to use in, let's say, outdoor situations. And then I have a last example for you, endless, it's about 3D printing of using robot arms. It's about reinforced plastic, so they print with the plastic and they are able to endless integrate glass reinforcement or carbon reinforcement to structures, and we have that one in our exhibition, a bicycle frame continuously printed with fibers, with glass fibers in that case, which is 30% lighter than a typical bicycle frame you know from the market. Yeah, if you want to see this example or the watch with wood inside, then you're highly welcome to come to the show, InnoDex area in Hall D. Thanks a lot for listening to me. Bye bye.
Tack så mycket, Sascha. Mycket intressant att höra. Och vi kommer träffa Sascha mer och höra mer under den här veckan. Hörrni, det börjar närma sig ett slut på den här första förmiddagen härifrån studion på Elmia Subcontractor 2021. Men, don't worry, vi kommer tillbaks. För efter lunch, ja, då är det dags för Elmia plats här. Vi pratar med Magnus Mörstam och Tech Arena. Mycket intressant. Därefter så kommer vi göra nedslag ute på det där vimlande mässgolvet som är i sin linda här i början, där det hände mycket spännande grejer. Vi ses därför efter lunchen vid klockan 1. Varmt välkommen tillbaka.